Yeah, so second talk's from Len Bellemore. Len is someone that us at Talent Point, I think, some of us has known for a little while. He's a platform engineering manager at Elsevier, looks after a team for the ScienceDirect product, right? And they've recently gone on a journey, contrast against the challenges that broad intelligence face. So he's going to share some of his experience about the ups and downs of going cloud native in that journey. Thank you very much, Len.
Cool. So a bit about me. So like Patrick, I've got a bit of a mixed background. At the moment, I'm platform engineering manager at Elsevier. I've been working in technology industry for probably 18 years, I think, thereabouts. Started out doing Windows stuff back in the day, Windows NT, Service Pack 6. So, all that stuff, no plug and play, that kind of fun stuff. I did a bunch of Windows stuff a long time ago, a bunch of networking stuff, and then I slowly moved into virtualization, a lot of Zen server, a lot of VMware, and then I started kind of working a lot more with Linux, and then I sort of found myself working with, sort of my life-changing or career-changing moment, I suppose, was when I found myself working with Apache Cloud Stack at a service provider in a team of one, me. And then I very quickly found myself leading a team of developers and cloud people and monitoring engineers and tooling guys and stuff like that. And I realized they were a lot better than me. So I decided to just be a manager. And I like it. So, yeah, I can talk about technology. I can't necessarily do it anymore. So please don't call bullshit on me for any of this. Cool. So now I work for Elsevier. I lead a team of cloud engineers, DevOps people, whatever you want to call it, on our ScienceDirect product, which I'll talk a bit more about in a sec. Before I go on, I just want to thank the Growable guys for having me here today. And thank Broad Intelligence for having us. And thank you guys for coming along. So I hope it's interesting. I hope you get more out of it than just beer. Which ain't a bad thing, but hey. And thanks to Patrick for the great talk. So I need notes. He didn't. So anyway, let's move on. Cool. So I am very much here as me and not as an Elsevier employee today. I'll talk about Elsevier and ScienceDirect and what we do because it's what I do, so it's important to me. But I'm just here for me and my experiences. So I'll take you through a bit about how we work with the cloud, AWS, for us, and where we got there. So Elsevier is very much the quintessential legacy business that in 1880 as a publishing company. So it's 140 years old, something like that. It's part of the Relics group. We're the E, the Relics group. We're the biggest company within that group. You might have heard of some of the things they do, like LexisNexis or Read Exhibitions, Comic-Con, that we own that stuff. But Elsevier itself, we started out as a Dutch publishing company, and we're all about scientific research. So scientific articles, books, journals, that sort of thing. I specifically work for the ScienceDirect product, which is kind of our flagship. It's all about, again, scientific articles. Elsevier is about 8,000 employees, I think, worldwide. 1,600 of those are in tech, and we're hiring a shed load of new tech people every year. Again, traditionally, we've been a publishing company printing stuff on paper. We still do print a lot of books and journals and stuff like that on paper, but as our customers move online, we're trying to pivot towards being more of an analytics company. We sit on a mountain of content. So what can we do with that content? So I have a lot of data scientists and these sorts of things trying to use that content in different ways. Instead of just selling it as an article for researchers, it's what can we do with that information? Can we help clinicians to make decisions and these sorts of things? So The ScienceDirect product that I work on, like I said, it's our flagship. We're the world's largest repository of scientific information. I say this a lot. I remind myself of this fact a lot. It's the whole kind of imposter syndrome thing that kicks in sometimes. So I rattle off these stats to myself to remind myself that I must be doing something right to be here. We've got 17 million scientific articles, about 34,000 ebooks, 3,500 journals. We'll download PDFs. It's all about PDF download. Not very sexy, but it's kind of important. About 2 or 3 million PDF downloads a day. It's impressive, right? It's cool. So now I feel better about myself. Elsevier was founded in the 1880s. Okay, so bricks and mortar, paper, very, very much legacy. The websites we did have up until, say, 5-6 years ago were pretty ugly, monolithic, data center based. Stuff broke all the time. But over the last 5 years, say, we've embarked on a huge, we're moving to the cloud. Everybody moves to the cloud. We shut down all of our data centers. We shut down the last one in the summer last year. We've hired a whole new breed of engineers. We're building big tech hubs around the world, London, Amsterdam, Chennai, Philadelphia, these sorts of things. Hired lots and lots of DevOps people. In some cases, for some of our products, we did a lift and shift. Not very cool, not very smart. But for some of them, like ScienceDirect, was built in 1997. Still going strong up until a few years ago. But they decided to build that from the ground up, kind of cloud native way. As a sort of incubator, you're in your own office with your own identity, your own team, rebuild it. And that migration process took about 4 or 5 years, I'd say. And they built the new ScienceDirect platform kind of alongside the legacy platform and slowly migrated traffic across sort of feature by feature by feature. We turned off the monolith last summer. ScienceDirect, it all runs in AWS. It's a microservices architecture. It's about 100 or so microservices. So it's not confusing or complicated in any way. We got SC Tech now internally to kind of differentiate it from SC Classic or the legacy monolithic platform, which is all written in C++. SC Tech is all written in Java, the back end, Node at the front end for the most part. And we rely heavily on AWS features. If AWS has it, we try to use it. So the old platform, to give you some context, 1 release a month maybe, something like that. Days of downtime in a year. And I mean, there's reasons for this. One is because it's 20 years old and it's hard to maintain 20-year-old software and infrastructure and whatnot. The new platform is automated from the ground up. So everything we do is fully automated. We're not deploying hundreds and hundreds of times, but we do kind of 2 or 3 releases, which is pretty good. We don't release on Friday just because we'd rather be in the power board or something like that than fix any kind of issues. But if we have to, we have to. It's kind of that you build it, you run it, DevOps style, squad-based model. We've got 7 or 8 dev teams, including the platform engineering team that I manage. Devs can deploy code whenever they want. It's kind of a non-event. So my team, I manage a team of about 10 people. DevOps, cloud people, whatever you want to call it. We're more around, our function is really, we're kind of a dev squad in a way. Our function is more around building those blueprints and that framework and the best practice around how to deploy. We run the CI/CD platform, that sort of stuff. And then we can go out to devs and just say, okay, deploy your stuff. If you need AWS resources. This is how you deploy it. Okay. So that kind of, you build it, you run it, everything's automated, which comes with its own pros and cons, which I'll kind of get into. A little bit about our tech stack. So again, the main purpose of ScienceDirect is to deliver scientific content. People download PDFs, right? They can view scientific articles in HTML format on the site, but at the end of the day, people download PDFs. A lot of researchers download PDFs to the laptop and print them. They do that. So we're all about PDF delivery. Okay. I never in a million years thought I would ever have to know so much about PDFs, right? Like, did you know, like, fun fact, like the PDFs we deliver, there's some scientific publishing community rule or best practice that scientific research the PDFs need to be built in a way that is viewable by, say, the very first version of Adobe Acrobat, right? In case of, nuclear annihilation, whatever, people still need scientific content. It's one of the Earth's or society's kind of, riches, So people need to do this stuff. So I did not know that. I know a lot about PDFs. So anyway, our platform, it's entirely Linux-based. We use EC2s, not containers, which we'll get to later on. We've got about 100 microservices, Java, Node. We run over 2 AWS regions, one in the US, one in Europe. We did a region migration last year, which was fun. Each AWS region runs active-active. So there's absolutely nothing that flows between the regions, right? We don't have any databases, okay? Which I'm kind of proud of. You're looking at me quizzically. You can ask me after that. Yeah. There are no databases. So each region is absolutely standalone. Okay, so we can drop a region and run out of another one quite happily. We'll probably go into Asia over the next year or so, but for now, we can cope quite fine with 2 regions. We've got, we run a set of continuous delivery pipelines managed by GoCD, which is our CI/CD tool. Everything's in GitHub, and we orchestrate absolutely everything with Ansible. A lot of products in Elsevier. So Elsevier is kind of chopped up into products. So if you know anything, you've done any scientific studies or in university or anything like that, you might know things like Scopus or Engineering Village or ScienceDirect, these sorts of things. So there's Mendeley. There's a lot of different products using kind of more or less the same tooling. A lot of them use Terraform, Ansible. It's just how it is. We like Ansible. Like I said, we do, say, 2 or 3 prod deploys in a day. Which is quite sufficient for what we need. All of that's fronted by Cloudflare. We moved to Cloudflare just a few months ago from another very large CDN provider, starts with an A. We won't talk about that. When we like Cloudflare quite a lot. We use Cloudflare to direct traffic between regions. We also use Cloudflare to drop region if we need to. And we also use Cloudflare for their WAF security as well, which I'll talk a bit more about later on. And we also use some of their edge computing technology, which I'll talk about later on. So I'm jumping ahead. So all of our instances are immutable, so they're short-lived. Every code deploys a new set of instances, new ASGs, new ELBs, that sorts of thing. So again, we do all that stuff with Ansible. Our traffic profile is very cyclical. It's the vast majority of our customers are universities. All right, so in the summer, it's quite low. Christmas, weekends, people aren't doing a lot on the platform. So we have to scale up and down quite a lot. So peak times, we run about 1,000 EC2s across Dev, QA, and Prod. Load times, say, about 400. Okay. So this is kind of our traffic profile for a typical week. You can also see the kind of breakdown in spot instances, the dark blue ones down here. These are reserved instances, AWS reserved instances, and these are on demand. So I don't know if you know much about AWS, but spot instances, cheap, yeah, 70, 90% cheaper than on demand. They can disappear within 2 minutes, though. Amazon can pull the plug on them, okay? Reserved means those are more consistent workloads. You're paying for those in advance. You pay for a year or 3 years in advance to Amazon, and they give you about, say, a 30% discount, okay? And then the rest are on demand. So our platform scales up and down. Dev QA gets shut down in the evenings, on the weekends, over Christmas. So we save quite a lot of money there. We also balloon up and down sort of throughout the day. Okay, and that's all, again, driven by auto-scaling groups, Ansible, that sort of thing. We save, for the size of our platform, we've got, like I said, about 1,000 VMs at peak time. It's pretty cost efficient, I think, compared to some other comparably sized sets of infrastructure. It's quite cost efficient. We're constantly trying to save money. Elsevier has about 10,000 VMs in Amazon, so it adds up quite quickly if you're not using things like Spot and whatnot. One of the things, this sort of scaling is great because our traffic profile is quite cyclical. I like how it just kind of works. We don't think about it at all. It just sort of goes up and down in this way and that way. I don't really think about it, That's because everything's automated, right? Which sounds nice, but the automation takes a heck of a lot of time sometimes, and as a manager who's, trying to manage timescales and things like that, it can take a bit of time to get that initial orchestration set up, So we're always looking at ways in which we can kind of speed up that initial setup time, especially if we bring on a new feature. If it's a new microservice, say, that's fine. That just kind of works. But if it's a new AWS service or any kind of new feature, sometimes it can take a bit of time. Also, we like I said, we use Cloudflare at the front end. We push about 16 terabytes a day of traffic through Cloudflare, so they really like us. But when we moved to Cloudflare a few months ago, the increase in performance was just stupid. It was just, we didn't do anything. We're just using vanilla Cloudflare CDN, and it was so much faster. Especially in kind of hard to reach regions well, not hard to reach, but areas with tricky kind of like India and particularly China. The performance really went through the roof. And we like, when I talk about cloud, I lump Cloudflare into that, and not just kind of traditional AWS. It'd be very difficult and very costly for us to deliver content in at the speed and scale at which, someone like a Cloudflare or a Fastly or something does it. We couldn't do that. It costs us tens of millions of dollars a year, right? These guys are putting up, 10, 15, 20 new data centers every year, right? You can't do that. They're in 160 or something data centers, right? We still have some issues in China. We have a lot of issues in China, actually. About 30% of our customers are in China. Another fun fact for you. The Chinese are the second largest producer of scientific research in the world. Within the next year or two, they will overtake the US as the biggest producer of scientific content. So not only do they produce it, but they consume it. Right? So our customer base in China is just going through the roof. So US, Europe, China, India, they're our biggest markets. But it's a global platform. The Great Firewall causes us a lot of problems. We are not allowed to host in China. You have to, as we're a publisher of content, and there's certain licenses you need in order to host content in China. And in order to do that, you have to kind of sign your life away to the Chinese government say, well, we then need access to your content, to your systems, these sorts of things. So up until now, we've not legally or from a regulatory standpoint, we've not been allowed to do that. That might change in future, but for now, we can't do that. We can't even use a CDN POP in China. So everything is outside of the firewall. Right? So we run into a lot of issues with, hey, they blocked JavaScript today. Or, hey, our domain name now resolves to Facebook, which means it's blocked in every single regional ISP in China. Right? Stupid things like this, right? And it's it's an absolute nightmare to try and troubleshoot that. Again, Cloudflare's help because it's bringing us closer and closer to the firewall, but some days it just doesn't work. Right? A little bit about security. I won't go in too much into the kind of meat and potatoes stuff about patching instances and things like that. We've got systems in place that kind of look for the latest Linux patches and whatnot, and then we've got an AMI bakery, so we can patch our AMI or our machine images, and then we say to the devs, hey, roll out your apps again, and they push out their apps and we're patched. So that's pretty easy. Amazon also does a pretty good job of patching their hardware. So things like CPU exploits and stuff like that are taken care of quite quickly. And because we can scale and whatnot, we don't care if they drop hardware out from underneath us. It's fine. It doesn't bother us. Our biggest problem around security is content theft. So again, the scientific publishing community is in a bit of a interesting time at the moment, where a lot of people are clamoring for free content, saying, for example, if public money was used to do the research, that content should be free, right? And you're seeing it's a wave, right? It's happening. So Elsevier and the other publishers in the industry, Wiley, Thomson Reuters, these sorts of things, Oxford University Press, these sorts of people, you can't stop it. But these companies are big beasts, and they are pivoting. So as we pivot, we need to try and protect our content. So there are a couple of big piracy sites out there, which a lot of people use. A lot of people think it's fair that they use them. I'm not going to get into that argument. We're here to talk about tech, right? But we are massive targets for content theft. So people take our PDFs and put them up on piracy sites. Another stupid thing, fun fact for you, another interesting thing about the publishing industry, scientific publishing, is nobody logs in. Almost nobody. I think 2% of our customers log in. You know how we tell if you are entitled to content? Your IP address. If you're on a university campus, hey, you can download whatever you want, right? This blew my mind when I first joined the company. Blew my mind. Just make them log in. Well, it's not that easy. People don't want to log in. Librarians don't want to log in. And librarians are powerful, right? If you're the I know you laugh, but if you're the librarian of MIT, right, or Berkeley, you have a lot of power. In charge of a multi-million-dollar contract with us or with Wiley or whoever, you have a lot of power. And they don't want to log in. So it's a hearts and minds thing that the whole industry is trying to get over, right? So if you have a compromised PC, or you just have someone that's given their credentials to someone, or just comes in and uses the guest Wi-Fi on, the university campus, you can download whatever you want, okay? Which is nuts. So we've got to think of other ways to try and stop content piracy. So one of our main kind of weapons, I suppose, and my boss likes to say this, and I'll quote him, it's an arms race, right? We do something, they do something, we do something, they do something, right? And I sit on this kind of content protection board, which is really interesting because it involves governments and FBI and all this sorts of cool stuff. But one of our big weapons is Cloudflare and their WAF. So again, if we're talking about cloud, right, we couldn't really hope to build the WAF capability that these guys have, right? They're tweaking their algorithms and stuff all the time, right? And they've got scale to be able to mitigate DDoS attacks and all this sort of stuff. We can't hope to do that. So we have to work quite closely with these guys to try and, as a blunt instrument, try and use their WAF technology to try and filter out things like, hey, this is a known dodgy IP address, so we're just going to block that. Or this is a weird user agent, like, just don't let that user agent download anything, right? Incidentally, there's all kinds of crazy user agents in browsers all around the world, right? People don't just use Chrome and Firefox, right? People download stuff through WhatsApp. Did not know that, right? So as a kind of a blunt instrument at the edge, we use Cloudflare a lot. But we have a content protection team, which has a bunch of data scientists. And they'll do things like take WAF logs and pump them through some kind of magic machine learning box. And also take our application logs and things like that, put them through the magic machine learning box, and then try and make decisions about whether or not that is a what they call abnormal usage, something that's suspect, right? So again, one instrument, dodgy IP, weird user agent, block or challenge, put up a captcha, something like that, right? And we can do that in seconds, right? It's easy. But the more complex stuff goes through magic machine learning box, makes a recommendation, fires that back at us in my platform via Amazon's queuing system, SNS, SQS, triggers a Lambda, which then fires in a rule into the Cloudflare WAF. So throttle this person, throw up a challenge, redirect them somewhere else, whatever, right? And then depending on the circumstances, that will time out after a while, or it's no, you're blocked until the security team calls you, university, says, hey, what's going on? That sorts of thing. So that's kind of some of the fun stuff we do with Cloudflare's WAF. And that's really interesting. That's kind of evolving all the time. So this is supposed to be me contrasting with Patrick about what's great about the cloud, right? So I'll tell a little story. So before I started working at Elsevier, I worked for a service provider for about 6-7 years. So managed service provider. We did data centers, hosting, all that kind of stuff. Rack them and stack them, cable them, that kind of stuff. Lots of VMware, lots of Citrix, Windows, Linux, all that kind of stuff. 24/7 NOC. It was pretty fun. It's fun time. So we had all the different silos. We had Unix team, Linux team, storage team, network team, data center team, virtualization team, all these different teams, the NOC. And it would take months to get servers racked up. It was crazy, man. It would have to go through all those different channels, right? You need a project manager to organize all this stuff, right? Change requests. And if something didn't work, I had to go back up the chain, So, you get your switch configured. Great, plug it in, doesn't work. Oh no, it didn't do that VLAN. I plugged the port or the cable into the wrong port, blah, 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 blah. So, times have changed now. Patrick's doing some really cool stuff in their data center, which I'm quite, I wish we had that years ago. But, I never want to go back to that world ever again, never. So, now I can do stuff in no time. Do you know what I mean? I remember one of the few times I lost my temper at work was I was running this Apache Cloud Stack setup, which is a private cloud, OpenStack kind of thing. And I needed storage. And he could not fathom how I did not know the exact IOPS profile of the storage I needed. I said, I don't know. I need lots of stuff. People are going to be doing all sorts of things. And we got this huge argument because I had to know the exact IOPS profile, So I don't have to do that anymore. Do you know what I mean? It's different game. So less silos. Handoffs suck, man. They suck. In ScienceDirect, we have two types of engineer. We have lots of developers, software engineers. We have DevOps people, and that's it. We have QEs, product managers. But as far as engineering, techie people, that's it. anyone can deploy anything. There's no handoffs. I'm broad brushstrokes here, but very few handoffs. Anyone can deploy really complex infrastructure. If you can read some YAML, you can deploy some really complex, cool stuff. And most of the time, people just push a button, and wait for a notification in Slack. It's done. Because, if it's templated, it's done. We couldn't do that stuff before. And, one of the drawbacks of, kind of the days of, all these silos, right, is, speak with my manager hat, is you have less responsibility, right? So, because you have 6 or 7 teams involved in deploying this one thing, right? If it goes wrong, whose fault is it? Well, it's that person's fault, that person's fault. I didn't get the right design doc. The project manager didn't tell me I needed to do this, blah, blah, blah. Now, if there's only one team that can deploy, anyone can deploy and anyone can fix. If it doesn't work, it's your responsibility, right? You got to fix it, right? It's your microservice, it's your thing. You have to fix it. So I like that kind of responsibility of working in the cloud, or rather working in an automated world, Which again, as Patrick's shown, you can get that in data center as well nowadays. Another great thing about the cloud is this infinite scale. I never run out of compute. Again, sometimes they do run out of T3s or whatever, but most of the time we can just scale up, right? So, and we do scale up. Sometimes in peak times or we don't have to worry about anything, and whether that's within the actual AWS infrastructure or more and more now, sort of at the edge, we're utilizing our CDN a lot more for caching and whatnot to kind of do some of that heavy lifting at the edge, even for things like denial of service attacks and whatnot. I don't have to worry about big Arbor boxes or anything like that. This CDN can cope to deal with that sorts of stuff. I can push code out in seconds, even into, say, Cloudflare. We use Cloudflare Workers, which is their edge compute infrastructure. 5 milliseconds globally, I can deploy code. It's pretty cool. Another thing that's really cool about the cloud is this things that used to be complex are just commodity now, right? So, another story for you. One of my kind of big light bulb moments a few years ago, working for the service provider. And I was building, I was managing a kind of a tools and monitoring team at the time. So it was a service provider, so SLAs were very important. Lots of reports around uptime and, number of change requests and all this kind of stuff. So lots of reports. And so I kind of found myself all of a sudden running a bit of a skunkworks dev team where we were looking at how we could integrate all these different systems to take alerts and route them, and stuff like Big Panda and VictorOps and all this sort of stuff we're doing now. We were kind of doing that, ourselves back in the day, and we were running all this in Apache Cloud Stack because the cloud was not for us at the time, and DevOps was not for managed service providers. I was told. So we were kind of doing this, not in secret, but on the side, shall we say? And we wanted to. We were also building a kind of a service management portal. We were doing things like integrating ServiceNow with monitoring platforms and auto-generating tickets and auto-resolving tickets and that sorts of stuff. We had this all running in Apache Cloud Stack, and I wanted to put some kind of geo load balancing so that I could drop a data center if I wanted to. Okay? So I went sniffing around the different teams and whatnot to say, how can I do this? And we ran a lot of NetScalers at the time, Citrix NetScalers. If you guys know this sort of stuff. I was told, hey, they can do that. Cool, all right. Spoke to the NetScaler guy, and he said, yeah, cool, they can do that. That's cool. You need a license, though. You need a new license on top of your bog standard NetScalers. Okay, I don't really have any budget for that because I was kind of doing this, secret squirrel style. And anyway, I can't do it for like a month because I'm tied up with client stuff. And it's really complicated. It's going to be tricky. And I'm like, shit, okay, well, what am I going to do now, right? So I started reading about how NetScalers did this. And it's DNS, right? It's just DNS at the end of the day. So I'm like, how do I do this? So I started doing some more Googling, going around the houses a bit. It's like Route 53, AWS, that's DNS, right? And they have this stuff, geo load balancing, global load balancing, whatever you want to call it. Did that, click, click, click. Hey, that works, right? Took me an hour, and it cost me $10. So that was the kind of aha moment for me, where I didn't need that license anymore. I didn't need that hardware anymore. I didn't need that specialist anymore, right? I could just go and figure this stuff out on my own, right? And Amazon taking all this complex stuff and just making it really, really stupid easy to use, right? So I kind of questioned all the stuff I'd known before that, right? But that kind of makes things, this is one of the downsides of cloud as well, right? Because I feel like I see people do things sometimes like, well, let's just open up SSH port 22 to the world, because that's easy, right? It's very easy to do things. We know that we can do things. We know how to do things. We don't know why we're doing it sometimes, So it's like, why have you done that? Well, because I want to log in. Yeah, but you know that anyone can then log into your server, right? And so, people can't troubleshoot a Linux box. A lot of people. And I think, damn, like, what is going on with the world, right? But then I think, well, we don't need to, We don't need to troubleshoot a Linux box ever again. Just shoot it and bring up a new one, High CPU, kill it, bring up a new one. So, it's a different world. So another great about the cloud is there's less financial red tape, right? So I'm a manager now. I care a lot about finance, budgets, and spreadsheets, and that kind of stuff. Cloud makes it really easy to spend money. It's super easy to spend money. We had a kind of a funny, not funny experience recently where, so Elsevier is big, right? And for example, ScienceDirect, we deliver content, we don't produce the content, right? There's another team somewhere in the world that is building this content. They're taking an article or a paper and they're translating it into some kind of PDF or XML that we then build PDFs from. I don't know. All I know is I deliver the PDF, right? But we needed to grab some stuff from an S3 bucket that another team has. So we did something silly where we had to call the S3 API, another product. Did that, cool, hey, it works. And then we have this really great, I say great, most of the time they're annoying because they bug me about budgets. But in this case, they said, hey, why have we spent $17,000 in S3 over the last week? There's this thing from you that's talking to it that's racked up 17 grand in S3 API costs. I went, oops. So it's really easy to spend money. Luckily, it wasn't my budget. It was someone else's. But hey. And they're in the States, so I couldn't buy them a beer to say sorry. But so, it's kind of a double-edged sword because it's super easy to spend money, but it's, it's great, but it's bad because it's easy to spend money. So the kind of the game changes. I don't have to go through all these hoops of procurement and getting things signed off and all of this kind of stuff. Months of delivery and all those sorts of things. Now I have the game has changed in that now I have a budget, right? I know what my budget is. And as long as I stay within my budget, I can do what I want, right? So if I wanted to say use a new service, I know that I might need to kill something else because I can't afford it, right? But as long as I stay within those parameters, I can do whatever the heck I like, right? Someone will remind me that I've gone above my budget. We have alerting and things like that. We use tools like Cloud Health, which is a VMware product now, to plug into the AWS API, and we can get cool alerts and stuff like that. But for the most part, I know that as long as I'm within those lines, I can do whatever the heck I want, right? And one of the things that I've found out over the last few years is that things like writing good code or troubleshooting problems, those are core skills to have as a techie. but cost awareness is also a key skill now, especially in the cloud, right? And this is something that I've been working hard on over the last few months to kind of educate particularly developers and product managers actually around this stuff costs money, okay? So my guys are acutely aware of it because they're buried in AWS all day long. But for the other guys, it's like, okay, this is a really cool thing you want to do, but it costs money, right? We can spend that money, but you know, let's understand what your cost profile looks like and things like that. It's easy to do, we can do it, but let's just understand how much money it's going to cost us, right? And again, when we have those guardrails, those budget kind of guardrails, it encourages everyone to always be optimizing all the time because they know we can't go beyond that, right? In hardware, you have a hard limit. You can only do so much, right? But in the cloud, you can easily burst beyond that. So it's got people thinking about, you know, how can we always squeeze a little bit more? You know what I mean? Like I said, Elsevier has, you know, spends tens of millions of dollars with Amazon every year, right? So any little tweak that we can do that saves 0.5% here or 1% there or a smaller instance size or whatever has massive implications. One of the downsides of the cloud is vendor lock-in, right? It's like a set of golden handcuffs. You know, it's so easy to do things. So easy, right? We got people just like, you know, use this feature and done this and done that. Like we don't roll our own Elasticsearch anymore. You know, we use Lambdas like you know, they're growing on trees. You know, queuing systems. You know, all this old stuff you used to roll yourself. We just use it, right? And so it's a really clever business model. Again, it goes back to that commoditization thing, right? It's so easy to do things, right? But then they got you. Do you know what I mean? We worry a lot about the amount of money we spend with Amazon, right? Because you have to have a lot of trust in them, right? And that could be Microsoft, Google, whoever. Because you have to trust that they're not going to jack up the prices. And, I mean, so far they haven't, right? It's a race to the bottom, if anything. But you also have to trust that their service stays at a decent enough level that you want to continue to work with them. And you have to also ensure that your business and technical relationship is solid with them as well. Because it's damn hard to get out. You know, it's really hard. And I see the same with our CDN. So my team rather spent the last 6-7 months trying to migrate out of our last CDN provider. It's only CDN, right? They're just delivering. You know? But it's more than that, right? There's so much more to it than that. You know, our old CDN was there for a decade, probably. Way before anyone was automating anything or keeping track of anything. So you had 40, 50 admins. Who are these people? No idea. Right? You had stuff in there that nobody knew what it was there for or why it was there. But you don't dare touch it, right? So to try and unpick all of that was damn near impossible, right? So now we're in Cloudflare. We like it. It's great. So let's pile everything into Cloudflare. We have auditing, and it's all automated, and it's lovely, and all that sorts of stuff. But we're going to use the shit out of it, right? So then we'll be stuck with them after that. It's going to be really hard to leave. So these big cloud providers, you know, whether it's the traditional cloud, like Microsoft and that, or any other, someone who's providing a SaaS service, something like that, make it so damn easy, but it's really, really hard to leave. But maybe Kubernetes can help. So we have to talk about Kubernetes, right? Right, we have to talk about Kubernetes. We haven't done it. We don't even use containers. We don't use Docker or nothing, other than local dev kind of environments. It's crazy, right? And I get people asking all the time, why aren't you using containers? Like, why not? Like, and I don't know, stuff works. Like, it's like, our platform's really solid. We have almost no downtime. Like, touch wood, it is stupid. It is so stable. I take no credit for that. My team is wonderful. But stuff works, man. You know, like, why rock the boat, right? We have a lot of products in Elsevier who are using containers, using EKS, Amazon's Kubernetes service. And they're kind of, everyone's sort of early stages of that, but they're liking it and it's good. but we're like, it's hard to justify going that way, you know? I think that some of the other products are liking it because they haven't had the mature CI/CD pipelines and automation and stuff, and this is kind of an easy route to that. We had the good fortune of being able to rewrite from the ground up. So again, stuff kind of works, you know? It can take a little bit longer to deploy or to get set up sometimes, but then it's kind of, you know, just sort of happens. It's easy. So we're kind of thinking about why do we want to do this? I don't have an ops team. You know, do I want an ops team to babysit Kubernetes? You know, I don't know. You know, I don't have an ops team. I don't really want to morph my team into an SRE team because they don't want to do out-of-hours support, really. You know, so yeah, do I want to do that? And Kubernetes is complicated. It's when stuff goes wrong, it goes very, very wrong. I mean, when I speak to mates of mine that use it and when I read and stuff like that. So, you know, I don't know. Saying, why the hell should I do it? And I'll tell you, we will do it. We will do it, right? Because I'm sure there's a reason people are doing it, right? And it is going to help us in some way. I don't know yet, but I'm sure it will. You know, and that's the weird thing is I probably will do it, and I'm putting my manager's hat on because fear of missing out, FOMO. You know, and that sounds really stupid, and that is not a good technical reason to do it, but that's probably why we will do it. Because we work in London, it's really hard to get talent. It's really hard to retain people, right? They want to work on the latest and greatest cool stuff, right? EC2 is our old hat, right? People don't want to work on that stuff anymore, right? They want to work on Kubernetes. So when we're trying to recruit people, so are you using Kubernetes? Nah. Or we have grads, we have people who just want to, you know, people want to learn all the time. They'll leave because they want to work on the latest and greatest cool shit, right? So, sounds stupid, but that is a compelling reason to do this stuff, you know? So that's a compelling reason to use the latest and greatest cool shit. Just because it's cool shit, that's why. So anyway. So we probably will do it. And truth be told, we've started dipping our toe a little bit in reading. Anyway, we haven't done much with it yet, but we probably will. Other than Kubernetes, what's next? A lot more with things like Cloudflare. We want to, you know, start tinkering out a lot more with their caching technology. But we really want to start looking into edge computing a lot more. We do a lot with Cloudflare Workers at the moment for PDF delivery, particularly around the security side of things, which I don't really want to talk about too much. But this is a really, really exciting field. You know, for a few reasons, right? I don't know if you know much about edge computing or anything like that, but to give you some context, it's like a Lambda or, you know, a serverless function. A thing that can run serverless functions in a way, but distributed through our content delivery network through the CDN. So, for example, in the Cloudflare world that I work in, if you want to run a function, a small function, you can deploy that function through their UI or API, and within seconds, they distribute that across 160 odd data centers around the world. Okay. So you can bring processing functions much, much, much closer to the end user, right? You're still constrained by things like CPU and resource and things like that, much like you are in a, you know, Lambda sort of world. So there's only so much you can do with it. But you can bring that processing much, much closer to the user. So for example, we deliver content to, I don't know, 100 countries around the world or something like that. And we can distribute some of that content back to the user in the CDN. But if there's anything more complex that we want to do, everything comes back to our two data centers, right? So to give you an example, and I don't know if we can do this stuff in the edge, but things like an entitlement check or any kind of, you know, a lot of our PDFs we build on the fly. You know, you add interesting images or tables of contents and these sorts of things, right? If we can bring that to the user and not have to wait for a round trip time to come back from one of our 2 data centers, that's going to massively improve performance, right? And not only that, it's going to save us money, right? Because we have less bandwidth costs into AWS, we have less compute power that we need to pay for in Amazon as well. So this is a really, really exciting thing. That again, we've done some cool stuff with it, and I think we're going to do a lot more with this over the next few months. So it's quite interesting. That's it for me, really. I'm there on Twitter and LinkedIn. Check me out. I hope that was interesting. That's it. Thanks.
Thanks very much, Len. Really good, mate. Cheers.